Okay, all right. Thank you so much for coming to our test one review for our MGF 1106 Unit 1 test. My name is Dr. Marjorie Hamilton, and I will be conducting our test review today, scheduled for 3:30 to 5:30. Please make sure you go ahead and put your name in the chat for me. Hi, everyone. Um, I'm glad you all could make it. I'm glad I wasn't here by myself. And what we're going to do is you already have your test reviews. I'm going to talk about the test just for a little bit so we can know exactly kind of what to expect on the test, what you expect to have given to you on the test. And then we're going to go through the second sample that you're given in your blank class notes. You should have the class notes given to you on your Canvas shell by your instructor. Your blank class notes has two samples in it right after you finish your lesson. And then the answer key should be released to you by your instructor, usually on your Canvas shell. Okay, so the samples that are given to you in your class notes are probably closest to what your test is going to be like. So we're going to go through sample 2 tonight. So you can have, if you have any questions, please feel free to answer. When you're doing your test review on your own, I encourage you not to look at the answers until you have officially tried the questions yourself. Give it 2 minutes per problem. With a lot of our questions, it's really look-see-tell stuff because a lot of the things will be already done. We're just answering the questions by looking at the Venn diagrams or the sets of some sort, and then answering the question by doing some observations. We're going to look at some different variations of those tonight. And then you have a test review given to you on your Canvas shell. That test review is more so more like your homework. So your homework is a little more robust, but the focus of that test review is more so you can work out your kinks of how to put your answer in to your put your answer into the your test. So if you are taking an electronic test, then this is really going to help you because you're going to look at your syntax error. And if that pops up, you want to make sure you pay attention to that. So doing the homework helps you to work out these issues. And then, of course, doing the test review online helps with that as well. If you're doing a paper version in your class, then you don't have to worry about syntax error, but you do want to, again, get that practice in. So when you're giving your answers to your instructor on the paper test, then you can give them as much information as possible. So when they're grading your test, you might have some partial credit going on there, which gives you more points on your test. Okay? So now, what are you going to get on your test? So this test, you do not have a help sheet on here that you're going to use, but you are going to have some help aids on your test. So we do have formulas that we are going to use or items or processes that we're going to do on this particular test. One big one is going to be your standard deviation. You're going to get that formula on your test, okay? You just need to know how to break it down and to solve for the standard deviation. So you don't have to worry about memorizing that formula. You're also going to get your normal distribution curve. You're going to get the percentages related to your normal distribution curve. So you're going to get the empirical rule, which is your 3 percentages related to that. I'm going to show us that, as well as the percentage breakdown underneath the curve. And that's going to help us when we're looking at the population and what population or percentage of the population that falls underneath the curve in different areas. So you're going to get that as well. So you don't have to memorize that. It's going to be given to you in the directions of the problem. Everything else you're going to need to know. So your symbols, your words, how they relate to each other, so you'll know what you're looking at. So tonight we're going to try to work out those kinks, try to make sure we know what the symbols mean, how the words relate to those symbols, so we can clear all of those issues up tonight. Does anybody have any questions before we get started?
Yeah, actually,
Mhm.
I don't see any like subsets or proper subsets on the sample tests. Will those be on our test or?
Everything that's on the sample test, everything that's on any type of test, sample or practice test will be on the test.
Okay.
I got a question. Can you hear me, Dr. Hamilton? Hey, everybody.
Yes, go ahead.
So I know I need help, a little bit help with unit 6, and it's the bars, I guess the equation, the formula for that. I need a little bit of guidance on that because I'm currently finishing up homework 6. The dispersion, and that's the only thing I need to gain confidence in, applying and working out all of those problems that's going to be on the test.
Okay. All right. We're going to try to work that out. All right. Wendell,
Thank
did you
you.
stand up?
Yes, ma'am. Where did you say the what we're using tonight? Where is it located at?
It's located in your blank class notes, right behind your Unit 1 material. You should see 2 samples there.
Where it says Module 1 class notes annotated, and then Module 1 class notes blank.
Right, the blank ones.
Okay.
Mhm. Okay. All right, we are ready, and I'm going to share my screen so that we can look at our first thing. So what I'm going to do is put up the information. We're going to work some problems, and then we're going to talk about it. Try not to look at your notes, okay? This is to try and see what you know right now, all right? I want to see what you know, and I want you to see what you know. So don't be afraid to ask some questions or just try it on your own and get it wrong. You want to get it wrong here so we can get it wrong together. You don't want to get it wrong on the test. All right. So here we are with our sample 2. This is coming right from out of your blank class notes. Okay. Can everybody see that? Can we see it?
Yes, ma'am.
Okay. Let's go ahead and see if we can work the first page. First page consists of problems number 1 through 5. Now, if Venn diagrams is your weakest spot, right, the weakest thing that you have, that's what we're going to work on that. Working on setting it up and then answering the questions. On the test, you really only are going to be asked to set up probably 1 or 2 Venn diagrams, period. Okay, everything else is already going to be set up for you. They're just going to be asking you questions about it. Is everybody clear with that? Okay.
Yes.
All right. So you're going to have 2 major things going on the test that you're probably going to have to do. One is that standard deviation problem. You're going to have to find that. And the second thing is probably setting up one of the Venn diagrams. And it may be that 3-tier one. Okay, that might be the biggest one. All right, so those are going to be your two big things. Everything else is already filled in. They're just asking you questions about it. But here we're going to do some fill in, make sure we clean up some issues, and then make sure we know how to answer the questions about them. So we're working it out. Working at our first page, 1 through 5. We're just going to take a couple of minutes to work on that. Give it take 8 minutes. All right, let's work through it. Make sure you have your calculator with you, the one that you are going to be using on the test. You should be working with that one at all times while you're working through your homework, while you're practicing your test material, so that you don't have any questions whatsoever on how to use your calculator. Okay. Should be moving good now. How many of us has made it to number 4 now?
I got the number 4.
Okay. We made it to number 4. Is anybody stuck on number 1?
Yep.
Yes? Okay. Do we need help setting up the Venn diagram?
Wouldn't for A be 3 and 7, and then for B be 12 and 5?
When you ask about would A be, what do you be those things? What do you exactly ask?
Like when you setting it up, A
Yeah.
and B, for A it will be basically 3 and 7 in that shaded area, in that area over A.
And right here, I agree with that.
And then
What's in the middle?
in the middle 2.
Okay, does everybody agree with 2 being in the middle?
Yes.
Okay, so starting there with 2 being in the middle. Okay, so when we're setting up our Venn diagram, we know we start in the middle, and we see that when we're looking at both of our sets, that 2 is in both of them, so that's why it's there. Go ahead and cross it off so you don't look at it again. Make sure you get it out of the universal set as well. And then you said that what's left in A was 3 and 7. I agree with that. crossing that out. Now what's left in B?
1, 2, and 5.
What is 2 left over here?
No,
'Cause
no.
2 is right here.
1 and 5.
Okay, so just 1 and 5, right? Is everybody all right with that? So 1 and 5 is gone and
Yes.
7 is gone. Okay. So now tell me what we have left going on.
3, 6, and 8 are left over.
Look again.
Oh, 4, 6, and 8.
Okay, so 4, 6, and 8, because 3 is already in A, and we already used that. So 4, 6, and 8 need to be out here in the universe. Is everybody all right? Now, what I like to do is I like to make sure that I have everything. So if you're not crossing off as you go along, then make sure that you go back and count to see that you have everything. So 1, 2, 3, 4, 5, 6, 7, 8. And that's everything in our universal set. We got everything accounted for. Is everybody all right with setting up the Venn diagram?
Yes.
Okay. All right. So now we can answer the questions. Now, could we have answered the questions without setting up the Venn diagram? Sure. All right. But if they give you a Venn diagram and somehow ask you to plug it in, okay, then you will do it. But if they don't, and you don't want to do it, then go ahead and just answer the questions, whatever feels good in your spirit. As long as you get the concept of whatever they're asking and you know what they're talking about. Say, for instance, A, and with this C right here thing, what does that mean?
Complement.
A complement. But what's complement mean?
Everything that's not in whatever is the, in this case, A.
Okay, so everything that's not in A. All right, so tell me what's not in A. What's not in A?
2.
I got 1, 4.
Okay, putting it in order, and look at A now. And what you do is take take 2 fingers and cover up the whole A circle. And then whatever you see, that's your answer, right?
Right. So it will be 1, 4, 5, 6, and 8.
Is everybody okay with that? Don't look at just this part right here. Okay, that's not just all of A right there. A is a whole circle. Is everybody all right? You have to look at these things individually when they're talking about it. So if they say a complement, you got to look at all of A. Pretend like B is just not there. And you're looking at everything in A. Now you're looking at, okay, if all of this is in A, what's not in there? So now what's not in there is all of this stuff around A. Does that make sense?
Yes.
Yes.
Okay. Tell me the complement of the universal set. Because we know that this symbol right here means the same thing as that C, right? So they're going to give you these interchangeable symbols right here, means the same thing. So the complement of the universal set, what is it?
An empty set.
What is it?
An empty set.
The empty set. How do we represent the empty set?
E and E.
Okay, but how do we do it officially?
A 0 with the line through.
0 with the line. How else?
Or
Empty
that's
brackets.
Empty brackets. Now, if this is a multiple choice selection, which I'm not saying this might be a multiple choice selection. I don't know. Problem number 12. I don't know. Okay. But if this is a multiple choice selection on the test, the only 2 official ways to represent the empty set are right here. That D and E is something that the computer or the program asked you to do in a certain situation. Does that make sense?
Yes.
The only way you can represent the empty set would be these two ways.
Can you explain to me why it's an empty set?
Well, the universal set has everything in it. Do you agree?
Correct.
All this stuff. So the complement of the universal set is the universal.
Okay, gotcha.
So the complement will be nothing.
Gotcha.
Okay.
Um,
Mhm.
can you explain when it's appropriate to use D&E?
When they ask you to.
Okay.
Say, for instance, we're going to do a problem where we actually have to use it.
Okay.
And then I'll talk about it.
So,
Okay. Sounds good.
so Dr. Hamilton, so just for, I guess, a way to look at it, for me to look at it and help me understand the complement, whenever it's that symbol, that mark is near any letter, basically we can look at it as like the complement making the letter a zero, like it doesn't exist. Is that a good way to look at it?
No, because it depends on what you're looking at the complement of.
Okay.
That only works with the universal set.
Okay, so what if that has like an A letter, like the complement of A or B?
Well, we did the complement of A for the first one.
Right. Oh, not a complement. I mean the universal, that mark. What is that mark called? The U?
The universal set.
Universal set. Okay. And that, Now, what is that mark is called? The universal set that?
This mark right here
Yeah.
is the complement.
Oh, okay. Why doesn't it have a C?
It's the same. It's just that
Oh,
they
okay.
represented two different ways. It's the same thing.
Okay.
Okay. It means the same thing.
Got it.
All right. So now we have N of B. What does N of mean?
Cardinality.
Number,
Cardinality. Cardinality means they want us to do what?
add them up.
Add them up. How many unique things are in there? What is the cardinality of our B?
6.
6, you say?
1 and 5.
And 2.
Well, I mean, it'll be 2. 1 and 5, it'll be 2 things in there, so it'll be 2.
I'm gonna say 3.
Okay. Because if we're looking at the whole entire B circle, again, y'all aren't looking at the whole circle. Do you see that?
I would say 8 if you add them all up.
This right here, if I can draw it.
It'll be 3.
You see this right here? This is what y'all are looking at. Y'all are looking at only this part right here. Does that make sense? This is what y'all are looking at. Is that all of B?
No.
No, ma'am.
Okay, so I need y'all to get it in your heads that when they're asking you to look at a set, y'all are looking at the whole entire circle and not just piece of the circle.
Got it.
This is really important, okay? So I need you to look at the whole thing and not just the piece you want to look at. Because then you're leaving out some stuff. So the cardinality of B would be 3. It doesn't go in a set because we know cardinality is just a number. It's the number of things that's inside of the set. And since we're talking about elements here, right? These are acting as elements. We're counting them. 1, 2, 3. There's 3 things in there. Does it make sense?
Yes, ma'am.
Yeah. Okay. All right.
So
What
it's
about-
asking for the number of the number that's like how many numbers that can be, not actually adding them all together.
Correct.
Okay.
This is different from in your homework when they gave you those colorful Venn diagrams.
Mm-hmm.
Okay, those, if you read the instructions in the homework, it told you that those represented cardinalities already. So they were ready to be added up. These are elements here.
Okay, okay.
You see the difference?
Mm-hmm.
So these right here, once we start looking at cardinalities, where we're looking at totals, then we'll start adding stuff up. Here we're listing things out. These are already just elements that we have. We listed them. So now we're just ready to just count how many things are there. And there's
Okay.
3 things there now. Mhm.
So when we need to add it, it will be clarified that that's what needs to be done.
Yes, because we'll be looking at different things. We're looking at total, we'll be looking at totals then.
Oh, okay, thank you. That was the
Right. When we're looking at survey data, when we're looking at, it'll actually say this is the cardinality, this represents cardinality. Then you know you're going to be adding up stuff.
Okay, thank you.
Mhm. Absolutely. All right. So now what's A intersect B?
2.
Okay. So we know A intersect B is right there in the middle. So in our set brackets, we got a set of 2. Okay. What about A union B?
1, 2, 3, 5, and 7.
Okay, so everything in the circles, union them together, we get 1, 2, 3, 5, and 7. Is everybody okay with this?
Yes, ma'am.
A union B 1. Okay.
Everything in the circles, put them together. Any questions about it? So making sure we tighten up on what our symbols represent, because eventually what's going to happen is they're going to give us the words that represent these symbols, and then we got to make sure we make the connection. What if they gave us a set? Here's set A. Look at it now. Then he wanted to know the cardinality of the set. What's the cardinality of the set?
The total.
5.
You say 5?
Yes.
Okay. Do we agree?
I say 8.
I say 8, yeah.
You say 8?
It's
Okay, what's the
5.
definition of cardinality again?
Number of elements.
What kind of elements?
Unique elements.
Unique. Okay, so can we count this 1 3 times?
Oh, okay.
Okay, can we count the 2 2 times if it appears to? No. So if it's unique items, then we're only counting stuff 1 time if it appears. What helps is if you rewrite your set with only listing 1 element that you see. So I only see 1. I see a 2. What else? A 5. A 6. I see a 10. And that's it, right? Yeah. So then count that. How many things? 1, 2, 3, 4, 5.
Dr. Hamilton, so basically you counting how many of each element you have.
That's the key word. Unique. Right? Only counts up 1 time.
Oh, okay. Yeah, that makes sense. I was wondering, it kind of threw me off a little bit because it had 2 numbers, like 2 1s and 2 2s, but we're only counting it 1 time.
So if I gave you, here's set B, and I gave you this set right here.
Mhm.
What is N of B?
Just 2?
Is it 2?
Yes, I think so.
No,
we
it's 7.
It's 7? Oh,
It's 1.
no, it's 1.
One
Oh,
unique.
yes, one. Yo, okay, it's one. I'm sorry, it's one.
Thank you. Okay, I'm about to say, I'm gonna write it if you tell me now.
Okay, thank you.
It's only one because even though I wrote it 7 times, it's only one number, the same number. You see that? So 1 is my cardinality.
Dr. Hamilton.
Mm-hmm.
So most of the time, like for the test purposes wise, they have a bunch of different unique numbers, like multiple numbers, basically, and then you just count them up.
Right, but only count it 1 time. If it
Gotcha.
appears more than once, just count it 1 time. Does that make sense? Now,
Yes, ma'am.
all right, so we're clear on the cardinality. And we're going to look at different situations now. But when they give you a list, right, that's what you're doing. And then we're going to look at some other ways. So we are looking at 3 now. Trying to move it through. Did we get to, given this set here, B, they gave us the set of all X such that X is an element of this N thing. What does this N represent?
Natural.
Okay, our natural numbers. And the part of the natural numbers we're looking at is where X is greater than or equal to 10. They want to know the notation in which set B is written is called what? What is this right here called? It has a name. We learned it. What is it called?
Set notation.
Okay, almost. You close. I'm with the set part. The other part starts with a B.
Is it the set builder notation?
There you go.
Parabola.
You're close. I think if you saw it on a test and there was an option, I think you would have picked it out. Set builder notation. Okay, so if you see this in a multiple choice selection, I'm just saying, and they ask you to pick it out, I think you'll be able to do it. Can we do it now?
Yes, ma'am.
Okay, we could be able to recognize it if we were able to pick it out. They asked us to do it. We'll be able to match it up. Okay, those persons who came in later on, please put your name in the chat for me. All right.
Okay.
So now it says write the set B using roster method. Roster means go ahead and just list out what we're talking about. So it says we're talking about where our natural numbers, the part where X is greater than or equal to 10. So if I'm going to write out that set, my set should start with what number?
1.
Greater than or equal to 10?
Greater than. So 10.
Okay, so pay attention to what it's saying now. Greater than or equal to 10. So that means that it should start with 10. And then what's my next number?
11.
Okay, and then?
12.
Okay, and then it keeps on going, does it not?
Yes, ma'am.
How do we indicate that it keeps going on in that pattern? What do we use?
The ellipse.
We're going to use those 3 dots we call an ellipse. So we need to know the proper way of using the ellipse. And here's a proper way. Here's one example. We started off giving our pattern, and then it goes on forever in that direction because it just says that X is greater than or equal to it. It doesn't say that it stops anywhere. And there's our set. Is everybody all right with that?
Yes, ma'am.
Okay. Then it says find N of B. Find N of B. How many elements are in this set?
All natural numbers.
It can't be all the natural numbers because all natural numbers start with 1 and we don't start with 1.
Oh.
Every
How many do you think? Even if we didn't start with one, is it still a lot?
Yes, ma'am.
Infinitely many.
Okay, infinitely many. How can we write infinitely many?
D and E.
We can write D and E right now. Okay, because it's too many to count. Do we agree?
Yes, ma'am.
We can write that. How else can we represent it? There's another symbol.
Is that the zero with the line through it?
Zero with the line through it means no solution.
No
or
solution.
an empty set. This is not empty.
an infinity sign.
The
Infinity sign.
Sorry, Dr. Hamilton, can you explain why number C, why letter C is D and E to me?
Does not exist means it's too many to count. We don't know.
Oh, okay.
It doesn't stop. So we don't know what it is.
Got it. Oh,
Okay. So instead of saying we know what it is, either going to put infinity, this infinity sign, or that they're going to say if it is infinity, they're going to tell you to put does not exist.
okay.
Because it's too many for you to count. Is that all right?
Yeah. All right, thank you.
Mm-hmm. All right. So there's an example of when we use that D and E. When it's too many, they actually want us to count some things, and it's too many for us to count. That's when we're going to use that. All right. Number 4. You see how they already have the Venn diagram set up? This is pretty much how it's going to look on the test. They'll give you a Venn diagram and then ask you to answer some questions. Have we answered these questions already? We need some more time.
Let's try this one.
Yes.
All right,
Please.
All right, take a couple of little minutes there and work out 4, 5. All right. 4 and 5. Okay, to make sure we move just a little to get to some good examples later on. I'm going to skip some problems now. So we're going to move just a little faster.
Okay.
Okay. Think about how they have the problem presented to you now. Remember, you got to find the pieces to get to the whole. So think about your order of operations really helps us with these particular setups here now. Think about that. Okay. And remember, try not to just look at it and try to see it all in your head. It helps to write some things out so you can make sure you're looking at the right thing. That really helps. Okay. All right. We'll be coming up on some good stuff now. Okay, we ready with A? Thinking about it now. Do we agree that the first thing we need to find is A intersect B?
Mhm.
Okay, we've got to find that first. What's A intersect B here?
1 and 6.
Okay, 1 and 6 right there. All right, that's where that is. But then they want us to find the complement of that. So that
Okay.
means what's not in here. Do we agree?
Yeah.
Okay, what's not in here?
2, 3, 4, 5, and 7.
Okay, 2, 3, 4, 5, and 7. Is everybody all right with that? Any questions? All right. Now remember, you all, you have some emojis and stuff right down at the bottom of your screen. Y'all can use those, give me some signs of some, thumbs up and stuff. Thank you, Sabrina. I appreciate you. All right.
So that means we're, oh, sorry.
Mhm.
That means
Go ahead,
we're basically we're excluding 1 and 6, that middle part where they share the numbers.
That's correct. Yes.
Got it.
All right. Give me the universal set.
2 and 5.
What is it?
Is it 2 and 5?
No.
It's 1, 2, 3, 4, 5, 6, and 7.
Good. Everything. Right? Remember, everything is in the universal set. So 1, 2, 3, 4, 5, 6, and 7. Your universal set is everything. All right. What about B complement union A? So there's no parentheses here, but we do need to find B complement first. So this is one of these problems where writing out the pieces so you can actually answer the question in the middle might be helpful. So tell me what B complement is first.
Everything that's not inside of the B circle.
Okay, so what is it?
2, 3,
2.
5, and 7.
5 and 7. Okay, agree with that. So we found that missing piece. Now we need to, here's our union. And then now they say they want us to union it with A. So tell me what's all in A.
1, 3, 6, and 7.
Okay. Good looking out. All of the circle. Wonderful. Okay, 1, 3, 6, and 7. So we've listed out our B complement. We're going to union it with our A. Now here I am answering the big question. So the big question is they want us to union all this together. And so our final answer should look like what?
1, 2, 3, 5, 6, and 7.
Everybody agree with that?
2, 3, 5, 6.
Make sense?
So that's just putting them all together, but not repeating any number.
That's right.
Okay.
Right. You don't want to repeat. So here's our union set. Any questions about it? How do we feel about our Venn diagram so far now? Are we feeling a little more comfortable about recognizing the symbols and what they're talking about?
Yes, ma'am.
Yeah. Okay. All right, if you just came in with us, go ahead and put your name in the chat for us. All right, now it says, name the ways we use the Venn diagrams in class. So there are 3 different ways we use our Venn diagram. What are those 3 ways?
Define unions, complements, and intersections.
Okay, no, now we are talking, we did use those ways when we were talking about how to put the things together. But there's certain ways we actually use the Venn diagrams and we gave them titles or names. So tell me what the colorful Venn diagrams in the homework were called.
Is it the cardinality?
We
No.
used cardinality.
Okay.
Right? So we used it where we were adding stuff together. How else did we use our Venn diagram?
Intersection.
No, we're not looking at our symbols there now.
Oh, okay.
Don't we have the Super Bowl coming up? What letters come after the Super Bowl name? What Super Bowl is this? It's like 40 something.
With the region, to find the regions.
Do you own it? Regions. And when we did regions, that's where our Roman numerals came in at, right? We had those Roman numerals in there. Okay, one more way. Think about it. We did. We just did it up here.
Elements.
Aha. Okay. If they ask you this on the test, and this is a multiple choice selection, I'm not saying it is, but if they ask you to pick out the 3 ways that we use the Venn diagrams, then you know how we did it. Is everybody all right?
Yes, ma'am. Where you been all this time?
Huh?
That's where you been all this time.
I've been right there.
Facts.
All right. So we know what is the cardinality of the empty set. What's the cardinality of the empty set?
0.
Thank you. Cardinality of the empty set is 0, right? There's nothing in it. 0 is the number. Okay. Look at number 9 and number 10. Here they're asking us to look or remember what our measures of central tendency are and the measures of our dispersion are. You got to know that stuff and know the difference between the two. Let's go ahead and work on number 9, number 10, and then we'll go ahead and look at number 11, which is a really big problem for us. Going to cover a lot of problems on the test, including that big one, standard deviation. We're working it out. Go ahead, take a couple of minutes. Think about it. Because if this is a problem on the test, I'm not saying it is, but if they ask you to pick them out, you got to be able to do it. Here's some good reviews right here. Show remind me of the test. Just saying. Mhm. Of course, here's a quick little hint. If you need help with number 9, just look at number 11. Working quickly, working efficiently. Okay, we're moving good through it. Can we go ahead and knock out 9 and 10?
Yes, ma'am.
What do we find out about number 9? The measures of central tendency. What are they? First of
Mean.
all, how many are there?
4.
All right, 4. What are they?
Mean, median, mode, and mid-range.
Okay, so the 4 M's. Okay, so for measures of central tendency, they're going to ask you to identify them. Maybe give you a list and ask you to just choose which ones there are. There's only 4 of them. The mean, the median, the mode, and the mid-range. You think about the 4 M's, you can't go wrong with it, right? What about the measures of dispersion? How many do we have?
3.
What are they?
Range, standard deviation,
Mhm.
and normal distribution.
Okay, all right. I agree with 2 of them. One does not belong.
Oh, so the standard deviation connects with the range, correct?
Okay, so those 2 belong. Okay, but the normal distribution stands alone. All right, it goes by itself. So measured dispersion, there's only 2.
So it's range and standard deviation.
All right. So range and your standard deviation. So those are your only 2 for your measures of dispersion. Now with the normal distribution curve, we're actually using the stuff that we learned to work it, right? That's why it stands alone, because it's something totally separate, but we are using the dispersion methods as well as part of the measures of central tendency together to work that, okay? Is everybody all right with 9 and 10? All right, so I need you to be able to pick those out of a lineup. Number 11, we're working it where they want you to find the mean, median, mode, and mid-range of this data set, and then find the standard deviation of it. Now, believe it or not, number 11 is probably about 5, maybe 6 problems on the test. Okay. If you can do this, that's 5, 6, 7. We're already over halfway through the test already. All right, just by what we done did. Okay.
All right. How many questions will be on the test, or are we not allowed to know that?
Well, actually, that question is usually an invalid question, and this is why I say that, because it doesn't really matter how many questions are on the test. What's important is, can you do what they give you?
Dr. Hamilton?
Yes.
Can you go back to number 10, please?
Sure. There's not that many questions. Not that many questions, because remember, a lot of them, some of them have moving parts, different moving parts. Like your normal distribution is going to have moving parts. So they're not going to give you a whole slew of questions.
So range and mid-range is different, right?
Yes. Mm-hmm. All right.
What's that bottom one on number 10?
Standard deviation.
So you only have 2 total things there. 2 total, range, standard deviation. Okay. All right. How do we find the mean?
You add all the numbers up and divide it by how many elements you have in there, which would be 7.
Okay. What do we call our total number of things? Our total number of pieces of data items that we have, what do we call that?
Cardinality.
In another case, we would, but when we're talking about our statistical data, we have a letter that we call it.
And a natural number, is it?
Oh, X bar? Oh, wait, no.
It's not a natural number, but you're pretty close.
That E
It would be N.
Thank you. It's going to be N. You're close with the natural number, so, but it's going to be at a little baby N, right? That's what one of the first things we learned when we went to our statistical work was that N equals the total number of data items that they give us. So right here, our total number of data items we have, you said was 7. 1, 2, 3, 4, 5, 6, 7. I agree. Is everybody all right? So if you're doing some statistical data and they ask you to add up how many people participated or what's the total amount of data items, then you know they're talking about your N, okay? So the mean, we're gonna take and add up all that goodness and divide it by our total number, which is N. All right? So now, plus 4, plus 8, plus 2, plus 1, plus 13, plus 5. Of course, you're going to do all this in your calculator. Let's start right here. Okay? Divided by 7. What are you getting for your mean? What did I get? Oh, okay, I know what I got.
I'm rounding it up to 38.
Your total answer?
Yes, ma'am.
Okay, now you added all this goodness up at the top and divided by 7 and you got 38? Or you
No. Yes, ma'am.
Okay, try it one more again. I say one more again. I did say one more again. Try it one more time.
Yep, one more again.
I think you might have added one of those numbers maybe twice or something.
I'm getting 6.
6. Okay. Because the number on the top, after you add everything up, what was it?
42.
42.
Okay, that's what I got, 42 up there. 42 divided by 7 gives us 6. So watch that. I'm glad that happened because, you know, sometimes those numbers will be written close together on the test and stuff like that. And so our eye will trick us and we'll write that or type that number in twice, or our finger will hit a wrong number in our calculator and throw us off. So just be very, very careful of looking at our screen to make sure that we got the right numbers in there. And double check before we push the enter button. I do it myself.
Dr. Hamilton, okay, so say in the data set or whatever, if a number repeats, that ever happens, I'm not sure if I've seen it with the median, and mode before, would you count the repeating number too, or?
If we have repeating numbers up here, if they gave us repeating numbers and we wanted to find the mean, yes, you would add them up that many times.
Okay.
Yes, ma'am. All right. So we're okay with 6 for the mean. Remember, your mean is your X bar. Okay, so this represents that letter right there, X bar. Okay, then the mid-range, how do we find a mid-range?
You gotta put them out in order, right?
Okay.
Add the largest and smallest number and divide it by 2.
Okay, all right. So that's right. We got to get the smallest, largest, divide by 2. And we're going to add them together. So our smallest number,
1.
okay, plus
13.
13 and divide by 2. So we get 14 divided by 2 gives us
7.
7.
Is everybody all right with that? Now, the mode, if it exists, what is it?
5.
It doesn't exist.
I mean, it doesn't exist.
It doesn't exist. So what does mode mean?
What's in the middle?
A repeating number.
No. Yeah.
Like the number that's like the most used in there.
That's right. So there is no mode. There's no number that repeats. So no mode. You can just write none, okay? But there's no mode.
Is it possible to have 2 modes, like more than one?
You can have 2 modes. That would be called bimodal. You can have 3 modes. That'd be trimodal.
Okay.
You can have 4 modes, and that could be like a whole lot of modes. Is everybody all right?
Got you.
Okay.
Yep.
Now we're ready to do the median. We've been talking about it all this time, but we're going to put it in the right place now. How do we find the median?
Now we put them in order.
Yeah, you gotta put them from least to greatest and then find the middle. And if the middle is not exact, you use two of the middle numbers.
Okay.
And divide by 2.
Perfect. All right. So let's put it in order. We call it ranked order. All right. So we're going to put it in order. Let's go ahead and put it in order, starting with 1. And then what else? 2.
4.
4.
5, 8, 9, and 13.
9 and 13. And you know what? What makes me feel good in my spirit? When I have to rank the stuff, I got to count it just to make sure I got everything. So here's 1, 2, 3, 4, 5, 6, 7. We know we got 7 things. Here we got 1, 2, 3, 4, 5, 6, 7. I feel good in my spirit. Is everybody all right?
Mm-hmm.
You got to make sure you don't miss nothing. Because sometimes you can be going fast and everything, and you're going to think you write something and you don't. It's better to be safe than sorry. Okay, so now we got our 7 things written, and we're looking for the thing in the middle. What is in the middle?
5.
5 is in the middle. That's our median. 5. Like I said, If it's two things that's in the middle, then we would have to find the mean of those things. Add them up, divide by 2, and that way we can find the middle of that. All right, but here we had an odd number of data items. So the 5 was right there. Everybody doing good with all A through D. All right, let's get to the gusto here with our standard deviation. Again, you're going to get this formula. All right, and now here we are seeing how we're going to break it down. Standard deviation now. Remember, the bulk of your work comes right here with finding this numerator part. Okay, and then we're going to bring it all together. So what's the first thing we need to know? And we already found it up here.
The mean.
Okay, we need the mean and we need our n. We got those two pieces already. So our mean is 6. All right, so we already have our x bar equals 6 and our n equals 7. So we have our n and we have our x bar. Now that we found those two pieces of information, now let's ready to go ahead and get our chart. Remember, if you got to create your own chart on your paper, your data items, it's good to list them in numerical order. It kind of helps. All right. And then your next column. All right. So this is our step 1, find your n. Your step 2, find your mean. Here's your step 3. Create your second column here, which is x minus x bar. And then your step 4 is going to be x minus x bar, and we're going to square our results. Is everybody all right so far with the setup? Go ahead, we're working it out. Go ahead and create or find the values for your second column here, which is x minus x bar. Remember, your data is your x. So you have x minus x bar. Go ahead and find your results, and then we'll verify. Take about 30 seconds to do it.
Repeat that one more time for me.
Say again.
Would you repeat what you just said? You want us to do what now?
I want you to find the second column right here.
Okay.
Go ahead and find the data items, right? Your results right there in that second column.
Will the mean always be the x bar? Is that where you get that from?
Yes, it's always x bar. Let's see. All right. Are we there?
Yes, ma'am.
All right. We know we're on the right track if our second column adds up to be the number 0. Okay, we know we're in the right, we're doing good if it adds up to be 0. Let's see. Tell me what you get for your first one. Should be something negative.
-5.
Okay, -5, and then?
-4. -2. -1. 2. +2. +3. +7.
7. Is everybody all right with these values?
No, how do we get?
Yes, ma'am.
How do we get what?
The second column.
We x minus x bar. Your x bar is, we found it earlier, it's 6.
It's 6.
1 minus 6 is negative.
Okay, I got you.
And just go right down the list.
Got you.
All right. So now, does this add up to be 0? I see it.
Yes, ma'am.
Yep. -5 and -2, that's -7, and that cancels with that 7. And -4 and -1, that's a -5. And this is a +5, that's Z. Okay, that cancels out. So that adds up to 0. We're on the right track, y'all. Is everybody okay? Now we're ready to take it on.
A quick question. So it always equals 0 for that middle column?
Yes. Mm-hmm. Yeah.
Okay, you kind of lost me a little bit at that point. How'd you get 0 now?
Just add up this column. And it cancels itself out. That's all. This means the sum. So we just add this up, you should get 0. If you get anything other than that, then you did something wrong with your calculation. All right.
So where did you get X bar is 6 and N equals 7? I had
We did that up here.
Oh, we're using that data?
Yeah.
Okay.
Mm-hmm. All right. So now we're ready to square these information. And when we square, there's nothing negative is here, because when we square a negative number, it should be positive. Let's go ahead and square these numbers. And what do we get?
25, 16, 4, 1, 4, 9, 49.
All right. Beautiful. Are we still doing good? You should not have any negatives here. If you
I'm trying to figure out how to punch that into my TI 30X 2S calculator for the -5 to be able to square it.
It should look like this. You should put it in parentheses, your hat button, and 2. Now you should have a X raised to the second power button. It should probably be on a face button or in a second function. But if you don't find it, you can use your hat button and then push the 2. So this is one option. But you should be able to put this -5 in parentheses. You got to use the parentheses. And then push this button right here. Again, it should be on a face button if you're using the 30X2. And then push enter.
Okay, Dr. Hamilton, I may be a little slow about it, but
I'm slow right now.
Could you go back to how we got the 25, 16, and 4? Like all those numbers in that column?
Again, you're going to take and you're going to square them. Take these numbers and raise them to the second power. Now, if you want to go old school with it, just go old school with it. -5 times -5.
Oh, okay, I see what you're doing now. So you did -5 squared, which gives you 25, then -4 squared is 16.
That's right.
Okay, all right.
Okay. That's where I was getting confused because I was putting it in my calculator, 1 minus -5 squared. I didn't know that we were just squaring the.
No, that's why I labeled this here, right? But then when I came here, we're going to take what we got from this column and just square it. So you don't have to do the work anymore. You already did the work here. All you're going to do is take your result and raise it to the second power.
The X bar 6 is the mean, right? That we got up here, up there.
That's correct.
Okay.
Any other questions? All right, so we squared all of our terms. Now we got to sum it up so we can get the total. What's our total here?
108.
Okay, so this adds up to be 108. Now we did all of this just so we can get to this part right here, this 108, so that we can fill it in right here. All that work got us this part right here in the numerator. So now we're at stage, this is step 5 right here. Now we're at step 6. pulling it all together now. So we have our standard deviation equals. Can't forget the square root sign. So the square root of 108 divided by, here's where we need that n. So n minus 1. The n is 7, so 7 minus 1. All right, so we're working it out in that calculator now. So we're going to get the square root. Here's 108 divided by 7 minus 1 is 6. Go ahead and do your 108, however you feel comfortable putting it in your calculator now. So if you want to do 108 divided by 6 and get that number, we'll see that it comes out to be a perfect little number, right?
Mm-hmm.
You should have gotten 18.
18.
Yes, ma'am.
So we should get the square root of 18. Now remember, you still got to take the square root.
So I have a question about this part.
Okay.
So I seen below that you said it was 3 decimal places over. So when it comes to the test, like, okay, can I say the answer now, or should I wait?
Well, let's go ahead, and when we put it in our calculator, we're going to take the square root of 18, and it's going to give us this long decimal number.
Mm-hmm.
Did everybody get the long decimal number?
I think, yeah, well, I think I put the, when I punched in this, the 108, and in my calculator, I got the decimal number. Like, I don't know how to get the square root of 18 in my calculator. I think I jumped straight to the decimal.
It's fine. If you went ahead and put this whole thing in your calculator, that's fine.
Okay, but how did you get 18?
How do we get it?
Yeah.
We just went ahead and said 108 divided by 6.
Oh, okay. Wait, 108.
Where does the 1 come from in 7 minus 1?
It's from the
oh, never mind. It's from the equation.
Yeah. All right, we're about to get to your question with the decimal number. So if everybody got a long decimal number starting with the number 4.
4.242.
Okay.
No, I did not.
No?
No, ma'am.
Even after you took the square root?
I'm still trying to figure out my calculator, if I'm going to be honest.
What kind of calculator do you have?
The TI 30X.
Okay, your square root button is over the x squared button. It's off to the left.
Oh.
Right?
Maybe.
If you have a TI 30X, then it's off on the first column, probably close to the 7. Wait a minute, let me see it.
Okay, I got it now. Whew.
Okay.
I was getting stressed out.
You close my eyes, look at the right calculator, because I got a lot of calculators in my head. But I feel confident it's over there. And you got to push.
Yes, ma'am, I found it.
Okay. You got to push the second button to get it.
Yes, ma'am, I found it.
Okay. All right. So we have 4.24. Look at here. I be dreaming about calculators coming and chase me now. Y'all got to work with me now. 4.242. And then you got 64. Then you got 0687. Did everybody get those numbers?
Yes, ma'am.
All right. Is everybody clear now about putting it in their calculator and getting the right number?
Nope.
Good. Okay.
Not me.
Nope.
No.
We're trying to figure it out.
Okay. Which part?
I mean, it's a bunch of symbols on here, but I'm trying to figure out which one to hit after
What calculator do you have?
the 30X2.
Okay, you still have to click this second button. It's at the very top left.
Oh crap.
It's whatever color your symbol is.
Okay, hit the second button and then
you get the square root button.
Okay.
And it should pop up on your screen with a parenthesis open. And then fill in your parenthesis. Either you're going to put in 108 divided by 6 or you're going to put in 18. And then push enter. Okay, go ahead with your question about the decimal. Somebody had a question about the decimal number.
Okay, yes, ma'am. So you said it was 3 places over, right?
That's right.
So I go 1, 2, 3 places over. It's gonna be in between the 2 and the 6, right?
That's right.
Okay, so would I leave the 6 or would I just go ahead and bump up the 2 to the 3?
Okay, so we have to bump up the 2 to the 3 because there's a 6 behind it.
Right. But
Yes.
we just leave it at the 3. We don't add the 6 and everything else, right?
No, the 6 tells us what to do to the 3rd place. You see? So if we're rounding it to the 3rd decimal place, we're going to look at that 4th number. And if it's a 5 or greater, then we're going to round that number up. If it's less than a 5, we leave it alone.
So what if there is like 4.9999? What would I do?
If it was 4.9999 and we were rounding to 3 decimal places, then we would round up. This is a 9 higher than a 5, and we would round this up 1 place. What'll happen?
0.
But then this will bump up since it's going up, right?
Yeah.
You see, so that's one of those ones where you go ahead and round up 1 more, and it'll keep bumping up because it's right at those 9s.
So would I add the 5?
You could. Some people, and then it depends on what the computer system that you're putting it in. They may want you to fill it in with those zeros to give you those 3 decimal places. So I've seen that happen. You have to actually still fill in those places.
Hey, Dr. Hamilton. Oh.
It depends.
So on the test, if we like have one of these problems, if we're solving the problems with the standard deviation, and our answer is like it has a decimal, either we write it a long way or we round up according to what the problem is asking us to do. Even if we write too many decimals, will we get points knocked off? Because I know like in the homework, especially on unit 6, it's kind of like it's like, I know for me, when I solved the problem, it was right, but they marked it off. I got it wrong because I added, I wrote out the whole, the decimal form like this, the long form. And then they had it where their answer their answer was like for instance, 4.24, they round up, and I was like, and my answer would be like this whole decimal. But at the next question, I would do it their way, like the short rounded up, and then they would, and I'll get that wrong, and then like, so I was very confused about. I think that was a technicality issue for that unit, but that's my question.
Well, if you didn't bring it to my attention, if you thought there was something wrong, and you didn't, I mean, like if you didn't bring it to your instructor's attention to say, they're asking me to round it here, I did, and it says it's wrong, then it might have been a technical issue with that problem. But if you didn't round it correctly, then that's why you got it wrong.
Okay.
You see?
Yeah.
Okay, so you just have to round it to where they're asking you to round it. So if they don't want you to round the 3 decimal places, that's where you got to stop. And if you don't, you're going to get it wrong.
Right, and I'll show you. But I ended up getting it right. But I'll show you. It was basically asking the same thing, like. But yeah, I just wanted to know that. But yeah,
show it.
Okay.
And sometimes some of the problems are glitchy. But you just got to bring it to your instructor's attention, and we can correct it.
Got it.
And correct everybody else's on too.
Yeah.
Okay. So is everybody okay with this problem now that we've rounded the 3 decimal places? So remember, find your 3 decimal place, or find your place where they want you to round. Look at the number behind it. If it's 5 or greater, round it up.
So you don't actually like completely you don't actually completely remove the decimal, or not remove, you don't completely like move the decimal point. You leave it in the same place, but after you round it.
Yeah, the decimal point never moves.
Okay.
Yeah, you're only just stopping the number at that place. Does it make sense?
Yes, ma'am.
Yeah, you're not
Yes.
trying to do scientific notation here, okay? Scientific notation is the only time you move it from decimal someplace. All right, that's not what we're doing. Wherever they want you to stop the number, that's all you're doing. Leave the decimal place alone. Just stop the number where they want you to stop it. That's all. All right. Any other questions about it?
No, ma'am.
Okay. Now this problem on the test, they may give you a chart like this and ask you to fill in these numbers. Okay. And then put your answer down here, rounded to whatever. It may be set up like that as well. So make sure you're filling in the numbers correctly if that's what they want you to do. All right. Number 12. I want to get to, let's get to number 13. All right, so we've done some Venn diagram work and stuff, and we'll try to see if we can hit that. But I want to make sure we hit our normal distribution curve with our percentages and making sure we know exactly what they're talking about with these percentages and with our z-scores. So number 13, you see how they give you the rule right here and the percentage breakdown even further in parentheses. That's how it's going to be on your test. You should have it just like this. So you need to know what these things mean and how you apply it to your normal distribution curve. All right, so go ahead and work number 13, setting it up, and then they're going to ask you some questions. Now this probably is 2 questions on the test. The setup of your distribution curve might be a question. And then another question would be, hey, we want you to find the percentages underneath the curve is a whole nother question. So that's how it might be set up. All right. Let's see if we can do it. Taking just a couple of minutes to work it out.
I'm gonna wait and let everybody figure it out because it's my first time doing this.
Why? Why is it your first time doing it?
My instructor, he just brought it up today.
I can vouch for that.
Yeah.
Also vouch for that.
Okay. And when, your test is next week?
Yeah.
Yes, ma'am.
I got 3 out of the 6 assignments as well too of the homeworks.
Oh, okay. Okay, I got you.
Yeah,
Okay.
my test is not till February the 8th, so we just starting this.
Okay. Oh. Okay. So,
Yeah, we're all kind of everywhere right now.
yeah, I see.
Yeah, and he also wasn't here for the first week, so we had to teach set and Venn diagrams pretty much to ourselves. And
Yeah,
then
that was a mess. It was a mess.
so your review has been very helpful.
Okay, well, I'm glad to hear that. That's good. Okay, well, since you all just learned it, okay, we all want to walk through it together?
Yes, please.
Okay. All right, let's do that. Okay, so here we are with our normal distribution curve, and we know that we're talking about the population is 100% of our population is underneath the curve. We are right with that, right?
Yes, ma'am.
The middle here represents what? What does it represent?
The mean.
The mean. Okay. That's our mean. Okay. So it says, suppose we have data that is normally distributed with a mean of 80 and a standard deviation of 10. Fill in the correct 7 data items under the curve. So they gave us some lines here that we can fill in. And we know we always start with our mean, which we know is in the middle. So here's our 80. And we know as we move to the right, now remember, this is just like a a real number line, right?
Mhm.
So when we go to the right, we're adding some stuff. When we go to the left, we subtracted some stuff. Is everybody okay? All right. But what are we subtracting?
10.
10. So every time we jump, we're jumping a 10 amount of 10. So if this is 80, then this is going to be what?
90.
Okay.
100.
110.
110.
Okay. And then when we go backwards, we get what?
70, 60, 50.
Okay. And 50. Okay. Now what I'm going to do is, here we see that these are my data items. I'm going to change my color. And while we're here, let's go ahead and put on my Z-scores. Because, you know, they might ask us in this question about some Z-scores. When we are putting our Z-scores on our graph, it's just like the real number line, okay? So our Z-scores, right here starting in the middle, our mean represents what Z-score?
0.
0. Every single time, right? 0. Now, if I go to the right, we know it's going to be some positive thing. And on the left, it's going to be some negative. Going to the right, what is it? Give me the numbers.
34.
We're talking about Z-scores.
Oh.
1, 1, 2, and 3.
There you go. These never change. 1, 2, and 3. And going backwards, did you get what?
-1, -2, -3.
-1, -2, and -3. These never change. They look just like the real number line. Do we agree?
Okay.
Okay, never change. These are going to represent how our data is distributed. Okay, and this again goes with our empirical rule right here. 68, 95, and 99.7% of our population. Okay, so now I'm going to go ahead and I'm going to label everything else too. Okay, let's go ahead and put our percentages underneath the graph because that's what they're asking us about. So when you're graphing this or writing this on your paper, go ahead and plug in everything so you can have it already ready. So now I'm going to change my color one more again. Let's go with green. Green is good. Okay. And I'm making a dark green because dark green is good.
Yeah, I'm
Okay.
glad you were explaining this because that wasn't explained last time I had tried to take this course.
Okay, here we go. These percentages is the breakdown of our empirical rule underneath here. So all these little areas are these percentages. So this is just 1/2 of our graph. So we're starting here at 34%. Okay, then we have 13.5%. That's what that means. Okay. Admit that. Okay. Then our next percentage is 2.35. This area right here represents 2.35%.
Is that on every problem? This is the same amount of percentages on every one of them?
This is the breakdown, yes.
Okay.
Okay. And then this little tail end right here, this little piece right there is going to be 0.15%. Now,
Dr. Hamilton.
Those
percentages, do we need to memorize those or will those be given on the test?
This is given to you. You see how it's written in the directions right here?
Yes, ma'am.
This is exactly how it's going to be on the test.
Okay. Thank you.
You're welcome. All you got to do is know how to add them up. We got you covered, I'm telling you. All you got to do is just add them up. But you got to know what you're looking for now. Okay, let's see what we got going on. Now, we already got 1/2 labeled. Let's label the other half. Remember, it's symmetrical. So we fold this sucker over. It's the same on the other side. So we're only giving you half of the graph. You got to fill in the rest. It's the same thing, 34%, 13.5%. This is 2.35. Don't need to memorize it. Gonna give it to you now. And then this part right here is at 0.15%. If you add up all these percentages, it adds up to be your 100% of your population, okay? All they want you to do is tell them, based on what they're asking you, what percent of the population falls between or in the realm of whatever they're asking. All right, so we've labeled. Now, let's go ahead. Now, if you want, you can put your empirical rule on there too as well. Do y'all want me to put that on there too so you can see where it is? Oh, y'all feel all right about it?
Well, what now?
You want me to put the empirical rule on there too?
Oh, yes.
Yes, ma'am.
Please.
Let's label that too. I'm gonna change the color one more again. Here we go. We don't have purple. Let's do it. So purple, here's the 68%. Remember the 34 and 34, if you add those together, isn't that 68?
Okay.
That's where that 68 comes from, okay? So here is from here to here. This is our 68, okay? One standard deviation from the mean is 68%, all right? Then you have 95%, represents two standard deviations. This is right from our notes now. So from here to here, from -2 to +2, I'm gonna bring it down low. This right here represents 95% of our population. Okay? Because if you add up all four of these percentages, that adds up to be 95%. And then your 99.7% goes 3 standard deviations from the mean. So from negative, okay, 3, all the way to +3. All right. I hope this you can see this. This is 99.7%. All the way over here. Does everybody see that all right?
Mm-hmm.
That's where all these numbers come from, okay? If you add these percentages up, that's where all these numbers come from. All we did was just found the individual pieces for you so that you wouldn't have to. So that if you needed to find just these individual parts, you had them already. Does it make a little more sense?
Mm-hmm.
Yes, yes, thanks for explaining.
Okay. All right, so now let's go ahead and work the problem. So now it says, find the percentage of the population that is above 110. So when we look at our graph, we're going to go to 110, and above 110 would be right over here, this little tidbit right here. What percentage is that?
0.15.
Did we have to add anything up?
No, ma'am.
Moving on.
Oh, wait, okay. So how do we get above 110 again?
We're right here at 110.
Go to the right.
What's above 110? This.
Oh, 1.5, okay.
All we're doing is reading the graph. We done labeled everything. All we got to do is just add up. But here we didn't even have to add that up. All we're going is to the right. That's above.
So are the z-scores in this formula going to be the same with every with the next, every problem of the 6?
No, it depends. Let's deal with it one step at a time.
Okay.
Don't merge. Okay? Because if you're looking for a z-score, you might need to use a z-score formula instead of actually drawing the graph. But you got an option. Okay? But here we just put the z-scores on here because we're labeling everything. And we might need to use it. And I think they have a question down here asking about a z-score. Yeah. All right.
Okay.
Okay. All right. So between 70 and 100. So where's 70 and 100? So 70 and 100. You see that area right here?
Oh, okay.
70 and 100. What are we adding up? 34.
34 and 13.5.
Add it up. What do you get?
81.5.
5. Oh, now
Is
I
it
remember.
difficult?
Wait, oh, hold on. So are we including 2 point? Oh, wait, it's 70. Oh, okay, only one. Okay, yeah.
Don't make
Yeah,
it
that-
difficult. We done did all the work.
Got it.
All you doing is adding.
I guess I'm concerned about if I'm filling out, is that filling out the chart exactly this way? Like the next numbers or the next data items that we get, if I can put it where it's at, it should be exactly, because if it's off, then I'm, yeah.
The only way it can be off is if you don't add right. And I mean, if the standard deviation is 12, then you just add 12 to each number. If the standard deviation is 20, you add 20 to each number.
Got it. So every time, whatever the mean is for the next problem, I should just put it in the middle, right where that I should, okay. And then I can go from there.
And the standard deviation tells you what you're adding or subtracting from the number.
Got it.
That's it. But the percentages don't change. That'll never change. All right. So what's less than 70?
16%.
Okay, so less than 70, you got 13.5, 2.35, and 0.15. That's what you adding up. And you said you got 16.
Mm-hmm.
Does everybody see what we're doing?
Yes.
Okay. All right. Above 60. So if we're standing here on 60, above 60 will be everything over here. Do we agree?
Yes, ma'am.
Everything. So 13.5, 34, 34, 13.5, 2.35, and 0.15. You adding up all of that. And you should get what?
97.5.
Wait, what number?
Oh, I think I did it fast. Hold up. Plus
97.5.
Okay. I think I heard 97 something.
0.5.
Okay, 0.5. Don't leave nothing off. Okay, so 97.5. Is everybody getting that number? All right. Make sure you use your finger and you getting all them crevices. Okay. If you got to write them out first before you put them in the calculator, you do it. All right. Tell me what percentages you're getting above 80.
%.
Okay, 50%. Do we even have to add them up?
No, it's halfway through.
It's just half of the graph. That's 50% right on. Okay, 50%.
Dr. Hamilton, how many of you said going to be on the test with these on there?
I didn't.
Oh, okay.
Didn't do it. But you don't have to worry. It's not going to be that many because you got other stuff to look at. All right. Now, what is the z-score, right? What z-score would be associated with the data value of 65? And look at your graph. What z-score would be associated with 65? What do you think?
Z-score. -1.5.
Okay, so here's our z-scores. And 65 is right in between here, right in the middle. We agree?
Mm-hmm.
Okay, so right there would be -1.5. Is everybody okay? Any questions about that?
So
Okay,
z-score would be associated with a data value of 65 is -1.5. So how did you get that again?
Again, find 65 on your graph.
Oh, I see it. Okay.
And we just
Got it.
reading it. That's why we label the z-scores.
And the z-square will always be 1, 2, and like just regular numbers like that, starting from 0 on up and on down.
That's right.
We'll always draw it like below the data items, like you have in this diagram.
It usually helps.
That helps a lot. It helps me a lot. Thank you.
Mm-hmm. All right. Now I know what you're thinking. What if they just asked you that question, right, without giving you a graph? Now, you have an option. You could draw the graph and see if you can see it, but we do have a z-score formula. Does anybody know what the formula is? Let me help you. Z equals. Oh, sorry. Y'all remember? Come on. Z equals.
Is it the mean minus the standard deviation?
Okay, you got most of it, and it's not minus the standard deviation, but we do have it because we know we're going to get a standard deviation. We know we're going to get a mean. All right, but it is in a fraction form. And they always give us data item. So data.
Are we talking about x minus x bar?
No. Oh. That's a different problem. So z-score equals data item minus the mean. And then we're going to divide it by our standard deviation.
Oh yeah, I've seen that.
So if they just ask you to tell what your standard or your z-score is, or find the data item that is related to, then you might just need to use this formula. But some people actually go ahead and just draw the graph and see if you can see it on the graph because they like the pictorial version. But then sometimes I want to warn you, if you go ahead and draw the graph, you might be able to see it on the graph. It might be very clear. But if you're looking for a z-score, sometimes that z-score is not very clearly seen on your graph. It might be 1.275. Okay, you can't see that when you're drawing it by hand. So you're going to need to use the formula then. Okay, so if they're asking you to find z of, right, they're saying what z-score is associated with this data value of 65. So they're asking you to find z of 65. This is our formula. 65 minus the mean that we had. Our mean was 80 and our standard deviation was 10. So when we do our math, we see 65 minus 80 was 15, right? But not just 15, but negative 15. Is everybody good with that?
Yes.
Divided by 10. Do you see it coming out now?
Oh yeah, yeah.
When we divide, we're going to get that negative 1.5. And so here's us using our z-score formula.
Dr. Hamilton.
Mm-hmm.
It was like a problem on the that I had seen on the homework, and it had said something about it had gave me, I think it gave me the z-score, but it had like it was like negative 1.1. It had gave me the z-score, and I was like kind of confused on like where that number was supposed to go, like when I tied it into the formula, because like it had said something like it gave me the z-score, I think, and I was kind of confused. How do I find the answer to that when they give it to me?
To find the data item, right?
Yes.
Yes. So if it gave you the z-score, then you would plug it in right here, because that's what the formula calculates, right? So you would plug in that number that they gave you. So say if they gave us negative 1.5, you would plug it in right here. And then we will be searching for this right here. This would be our unknown value that we're looking for. And then you will solve the equation for that value.
Okay.
Does that make sense?
Yes, ma'am.
Yeah. So you'll plug in what they give you to solve for the unknown of what you're looking for. And you're looking for two things. Either you're looking for the z-score or you're looking for the data item. And most of the time they want you to find the z-score, like in the homework, like you're saying. I remember that problem. They asked you to find the data item by giving you the z-score. And they gave you the mean and they gave you the standard deviation. Yeah. So is everybody clear about this z-score formula and how to use your graph to find the z-score?
Yes, ma'am.
Okay. All right. So those persons who just got to finish seeing the normal distribution for the first time, is everything's a little clearer?
Yes, ma'am.
Yes, and that formula was that we should use when it's not always easy. Like if it's like if it was like 67, we should like that would be a good scenario to use it.
That's only when you don't think that you're not sure if the z-score is going to be clearly seen, but you won't know until you graph it.
Okay.
Yeah, it's hard to say if you can see it on the graph clearly or not, because you don't know how you're jumping with the numbers and whatever they're asking you for, if it can be clearly seen on the graph until you actually graph it. But if you graph it and you say, wait a minute, that number that they're looking for is not in the middle. It's a little more closer to the number, then you know it's going to be some funky decimal, some bigger number. Then you got to use the formula.
Thank you. And that formula won't be provided, correct? That's something we should know.
Know this formula.
Okay, just to double check.
You got to know that. Okay. All right. So talking about a couple of little things before we go. Everybody's okay with stem and leaf plots?
No, ma'am.
Yeah. Oh, I think I'm pretty good with it. But
yeah. Okay. So again, they asked you to list the data from it. Okay. So stem means 10, right? Your 10th place, your leaves is the ones place. The only difference between the ones here in the lesson and the ones in the homework is they don't separate the numbers with a comma. They just write the leaves close together. So the numbers are close together. All right. So if we wanted to list our data here, give me my first row of data. What would it be?
Be 1, 4, and 8.
Okay, 1, 4, and 8. Because our stem is a 0, that means that there's no 10th place. So we just talk about the number 1, the number 4, and number 8. Give me the second row.
10 and 13.
Okay, so 10 and what else?
13. 13.
So because we have a 1 in the stems place here, our 10th place, we have 1 and 0 makes a 10. This makes a 13. Does everybody see how it's working now?
Yes.
Okay, now the last row.
20, 25, and 25.
Okay. So there's our data listed out. This is just another way of us representing those data items when they give it to us in the list. Okay, what's the mode?
25.
25 is the one that appears the most. 25. Tell me what the median is.
Is it 11.5?
Okay, is it? What numbers do you have to work with?
10 and 13.
Okay, so right here, you see that it's an even amount of numbers. So we have to look at 10 plus 13 divided by 2. And that gives us that 23 over 2, which equals, what number did you get? 11.5. Okay, so our median, 11.5. Is everybody okay with it?
Yes.
Any questions about the stem and leaves plot and how to pull the data out and then answer the questions about it? All right. Frequency table. It's a grouped frequency table, and they're going to ask you these questions about it. What is the class width? The
4.
class width. What do we say?
4.
Or how do we find it?
I'm just
Oh,
looking at the
We
data
add up the
item.
frequencies.
no, not for the class width.
I'm
Because
looking
the-
at the data. I'm looking at the data items, and each one all the way down is like 4 all the way down. That's how I pretty much did it.
Okay, so you just count how many things are in each one.
Yes, ma'am.
Okay, what's another way we can find out? Because I'm all for the counting. Counting is, here's 1 through 4. So 1, 2, 3, 4. So that's 4 things in there. 5 through 8 is 5, 6, 7, 8. That's 4 things in there. 9 through 12 is 9, 10, 11, 12. That's 4 things in there. So my class width is 4. So I'm all good for using my fingers. You can count, but you can also subtract the adjacent lengths. So if I went from the lower class limits and subtracted, right? So 5 minus 1 gives me 4. 9 minus 5 gives me 4. You can use the upper ones too as well. 8 minus 4 is 4. 12 minus 8 is 4. Do you see that? You could just subtract the adjacent class limits, and that'll tell you what the class width is. The class width just says how many values are accounted for in each one of our classifications. Does that make sense?
Yes, it does. But on my homework, it has where you have to make your own data chart. How would you be able to determine the datum item for each row?
Usually they start you off with a pattern. Like they start you off with one and then you finish.
Okay.
Okay, but what it is a frequency table is only usually no more than 5 or 6 rows. That's as far as a frequency table will go. So based on the number of items, like the highest number you have, that's how you can kind of determine how you're going to fit it into that table. And that's how you group it, if that makes sense.
Okay. Yes, ma'am.
Yeah. Okay. All right. So what is the upper class limit of the third class?
12.
12.
Okay. So upper class limit of the third class is 12. Good. What's the lower class limit of the fourth class?
13.
Okay, 13. Remember, these are our classes, and these are the lower limits, and these are the upper limits. All right. Now tell me what my N is.
Is this always 0?
67.
No, it's not 0. Where'd you get 67 from?
Adding the frequency.
The frequency is your N. Okay. So N equals comes from your frequency. You add this up, and that tells you how many pieces of data we got. Remember that?
Yes.
Right? Okay, so your N is always your total number of frequency. Let me say 67. Is everybody all right with the frequency table, the group frequency table?
Yep.
So we got so for N, we just added up all the items that were in the frequency column.
That's right.
Okay. Phew.
Yeah. Total number of items that you have. That's the frequency, because this is the total number of how many times these things appeared, right? So that's your total number of data items. All right. Can we work this class? Mm-hmm.
I have to run to work. I'm running late. I just want to say thank you for your help. You helped me out a lot.
Oh, wonderful. Thank you so much. Have a good day at work.
Yes, ma'am.
All right. One more with our Roman numerals. Okay. Thank you, Gavin. All right. So Roman numerals, looking at our regions. Okay, they're going to give you this Venn diagram, and then they're going to ask you some questions about it. Let's just answer some questions real quick about it. Tell me the regions that represent set B. Tell me what's in set B.
2, 3, 5, and 6.
Okay, 5 and 6. Remember, these do not go in your set brackets now. Okay. Now this problem right here on the test will probably just be where they give you the Venn diagram, and then each question they're going to give you some selections, and you just select the ones that you want. You don't even have to type them in. It's just going to be where you select them. Okay. Now tell me what region represents A intersect B.
2 and 5.
Okay, we got 2 and 5. Do we agree?
Yes.
Yeah.
You see it? Okay, good. So 2 and 5. All right. What about A, union B, union C?
All the numbers
1, 2,
except
3,
for
4.
Except for,
the one in the universe.
okay. So everything in the circles. So 1, 2, 3, 4, 5, 6, and 7. Is everybody okay? All right. What about A union C?
1, 2, 5, 4, and 7.
Is that it?
And 6.
Okay. 6, 2. Okay.
Okay, yeah, I see it. 6 and
You see it?
7.
Okay. So everything right here in those 2 circles. So 1, 2, 3, 4, 5, 16. Is everybody okay?
What is the third one for B? For D, I'm sorry. For D, what is that
1,
third?
2, 4, 5, 6, and 7. Thanks, Irma. Okay. All right. Now the cardinality of A.
D and E.
Okay. Why?
Because you cannot determine the cardinality
Okay. You can't. We don't
in the
know.
region.
We don't know anything about the cardinality of regions.
So this is the one on E that no matter what it is, we would never know the cardinality.
That's right.
Okay, okay.
Yeah, they don't tell us anything about the regions. We don't know what's in it. Could be some villages up in there. We don't know. Okay. We just know we talk about areas. We just don't know what's in it. There's not enough information. All right. So do we feel better about the test?
I do.
Yes.
Yeah.
Yes, ma'am.
Okay. So as you're starting to continue your learning about the information, hopefully this helps. Continue going over. You still have another sample. Use that as extra. You can go back over this. You have a blank one. Get get a copy again. You can do it on your own without looking at the answers, and then check behind yourself as many times as you need that you feel comfortable with it. And then go and do the one online and make sure you know how to enter your answers in, how they want you to enter it. And then you should be good to go with the test. All right.
Thank you.
Thank you so much for your help. You're
Hamilton.
amazing.
Dr.
So
Hamilton.
welcome. If you have any questions, you can kind of hang back. I have a few minutes and I can answer those for you. But thank you so much for coming out.
Dr. Hamilton.
All right, and good luck with your test. Yes, sir.
Thank you. Bye-bye.
Bye-bye.
I need to see 13.
Number 6.
For sample, what was it?
There it is.
For sample 1.
Number 13.
For sample 1.
For sample 1.
Mm-hmm.
Oh, we didn't do it. Oh, I passed it. Right there.
Mm-hmm.
Okay, there it is. Did anybody else have a question or anything?
I have a question.
Yes,
So
ma'am.
my class, I think, is a little behind and we still have our exam on Wednesday. So if I just do the test, I mean, that sample 1 and sample 2, that's all that's going to be on the test and I'll be fine.
Yes. Yes.
Okay, so as long as I have all that information down, I'm able to like to go on the test. And also, by any are we allowed to visit you for office hours too?
Yes, if you want, you can stop by.
Just in case I have any questions, like before the exam or as I'm doing it throughout this because the way you explained it, very easy for me to remember. So what office hours do you have?